I'm back. Okay, so we've just learned about Rawls' theorem, and now we're going to talk about mean value theorem. Remember, mean means average, at least in my brain, and the way they've made me memorize that. And so now mean value means I'm finding an average, which I am when I do slope, in that I'm taking the two endpoints and basically adding them together and dividing by the total distance between them. Okay, so now back to have a continuous function, has to be differentiable. So continuous on the closed interval, differentiable on the open interval, so that I don't have the problem of not being able to take the derivative at the endpoints. And then if I have that, so there's some number c who's in between these two guys, and you can see c over here in my picture in between them, such that his instantaneous slope, so remember this is my first derivative, that's instantaneous, and that means the slope at the point. So instantaneous meaning I took the derivative and I found the slope at that point, is equal to the slope from the beginning point to the end point. And so remember that this point right here is a and f of a, because that's the y value, and this point on the right is b and f of b, and so rise over run would get me, which is this formula, my slope. And if I can see that orange line and the green line, they look parallel, so they should have the same slope. So the instantaneous slope is equal to the average of the between the 2 points. Okay, so now main significance for mean value theorem is that, as I said, the instantaneous rate of change, that's my first derivative, is equal to, so that's this piece, is equal to the average rate of change. Remember back in chapter 2, we called that v average, or maybe chapter 1 when we were looking at velocity. Okay, so let's look at some examples. So in order to determine if Rawls' theorem can be applied, this is my little checklist. So I have to see, is it continuous? Is my function continuous? Is it differentiable? Is it closed? And is the y value at the beginning the same as the y value at the end? So here's my first function. Of course, if I remember, sine graphs look something similar to this. Of course, that 2 pi is going to change the period of it, but nevertheless it will still be cyclical. So yes, it's continuous. When I look at it, it's continuous from -1 to 1, and it is differentiable on the open interval from -1 to 1, so that's a check. It is closed, so I went from, again, -1 to 1, and I gotta check, is the f of a equal to f of b? Well, so my beginning point is -1, so I've got to check, is f of -1 equal to, put a question mark above that, f of 1. So I'm going to plug them in. And so I find out, hey, f of -1 is equal to f of 1, so that's a check. So I can apply Rawls' theorem. And now I'm going to find c such that my derivative is 0. So let's see. I guess the first thing I would need is to take the derivative. So f prime of x would be cosine 2 pi x. Remember, this is the inside, and then I got to take the derivative of that, which would just be 2 pi. I'll stick it in the front as a coefficient. And so I want to set this thing equal to 0 because that's what it says. So I would divide by 2 pi, both sides. I'll get cosine 2 pi x, still 0. And then inverse cosine, which gives me lots of possibilities. Here's 5 in red. And then I finish solving.